All right, so far we have only been looking at trig functions in the first quadrant, or trig functions with an acute angle. And we need to expand that into the entire rectangular coordinate plane. So we're going to revisit kind of some standard position ideas, and then we'll transfer that into how we're going to find trigonometric angles in different quadrants. So if I just want to review, if I have an initial side right here, and then an angle of 30, you would just open to 30 degrees right here. Remember, negative angles go in the opposite way, so our initial side lies here on the positive x-axis. And then I like to label, so this would be negative 90, this would be negative 180. And so 135 would be 45 degrees past 90. So draw it this way. Like so. All right, so let's say that the point P is at negative 3, 4. So it's here in quadrant 2. And that's one of the points on our terminal side of the angle. So that means that this is probably our angle here. It could be the other way, but I'm going to just draw it from a positive perspective. All right, now if I wanted to find the value of the 6 trigonometric functions, though, that's going to be a little bit tricky because we've only learned them so far in this first quadrant. So one thing that we're going to be doing here is we're going to be looking at this as a triangle here with a base of x and a height of 4, negative 3, because we're in this direction. And if you know your Pythagorean triples, you know then that this is 5. And I'm going to use this triangle with an x and a y like this and an angle of 5 to try to figure out what the trig ratios are of this theta. But I don't know this big theta here, so I can actually use this piece as my theta, and it just so happens that that's going to be our same trig measurements. We call this the reference angle. We'll do that just a little bit and find more of those, but that's what we call this piece right here. So that means the sine of theta must be still opposite over hypotenuse. The cosine is going to be adjacent over hypotenuse. Tangent is going to be opposite over adjacent. Cosecant will be the reciprocal of sine. Secant will be the reciprocal of cosine. And cotangent will be the reciprocal of tangent. All right, let's look at one more example of this type. So if I know that the sine of some angle in quadrant 2, again, is 3 and then 7ths. So here is my initial. I'm somewhere here in quadrant 2, and this is my t. This is my angle, or my arc length of time t. But the right triangle, that I'm going to make goes here with the x-axis. Because this is the point here, xy, it makes the most sense to drop it down here to create that right triangle. Right, so that means that I can use this as my reference angle piece. And so sine is going to be 3 over 7. What that then helps me find is I can figure out cosine. So if I call this A, B, and C, I know that 3 squared plus B squared has to be equal to 7 squared. I know that 9 plus b squared must be equal to 49. B squared must be 40, and so b must be, in this case, it could be plus or minus because b is on that negative side, right? So we would actually have the negative because my x is in the negative direction, so negative square root of 40. I could take out a 4, so I'm going to say negative 2 root 10. And so therefore the cosine of t is going to be negative 2 root 10 over 7.